All right, guys. Hopefully you can see what's going on here. This is my first attempt at using this particular brand of software. We're all branching out and doing new things. So, I'm coming at you live from my basement. We have some people cleaning the house upstairs and thoroughly disinfecting the whole place, which is pretty great, and it helps support them in these hard times. And so the other chemistry teachers and I were talking, and we sort of came up with sort of common questions from the most recent activity we've done this week, the "What is a Mole" activity that you did through the TED Ed website. And I wanted to kind of give you a brief summary of kind of why we assigned that, what the connection is to actual chemistry that we're going to do moving forward, and sort of information that will help you figure out what to do on the quiz. The title of this, as you can see, is "What is a Mole Anyway?" We've been talking about this mole for like a month now, and the reason we talk about the amounts of chemical substances in terms of moles is for some of these reasons. So single atoms, as you can see here, they first of all are tiny. They're impossible to see with the naked eye, and therefore they're really hard to visualize. One of the hardest parts of teaching chemistry is getting you guys to understand some really sort of abstract concepts and make them concrete, make you actually be able to kind of visualize the things that we're talking about. And atoms, I think you can agree, are kind of hard to visualize, especially in terms of how they react with each other. And frankly, when we're doing math, when we're doing real chemistry, like carrying out reactions and figuring out how much we should expect to get from a certain reaction, for example, it's not super useful. We talked about the concept of an atomic mass unit, that is the mass of a single atom, but we never really actually do reactions with single atoms. We would have to be at the level of an atom to be able to actually pull that off and to do it successfully. So that is one of the big reasons why we don't really talk about single atoms when we get into talking about chemical reactions like we have recently. So if you'll allow me to scroll down a bit. Now, a mole of atoms is where we're at right now. Now, this is a big number. It's referred to as Avogadro's number. The numerical value of that number is 6.02 times 10 to the 23rd, or I believe the tutorial that you went through described it as 6.02 sextillion, or 602 sextillion, rather. It is a big number, 602 followed by 21 zeros. If you're in my class, and I think in all the other classes as well, we actually wrote that number out on the board, and it's outrageously large. And so a lot of you were asking, at least in my class, like, where did we get that number? Why is it 6.02 times 10 to the 23rd? It seemed kind of arbitrary. It seemed like whoever decided what a mole was just sort of made that up. But there's actually a pretty good logical explanation for what seems like a random number. A mole is defined, or was defined back in the day, and I believe the video refers to this, as the number of atoms, I'm not good at proofreading, in about 12 grams of carbon. If you look on the periodic table, you'll notice that the mass of carbon is 12.011. It's as given on the periodic table, and basically what scientists figured out is that if we had about 12 grams of carbon, that amount of carbon would contain about 6.02 times 10 to the 23rd atoms. The ways in which they measure that sort of thing are way more sophisticated than anything we would do, but we use that as sort of a numerical definition that helps us understand how substances react and how much of each substance reacts. So, the other reason why it's so important to know a little bit about the mole is that it's super useful. It's good for all kinds, there's that proofreading again, of calculations. We've talked at length about the concept of a molar mass, the idea that 1 mole of a substance, that big number of atoms, is equal, the mass of that mole is equal to its atomic mass in grams. So for example, the example I gave the other day in my class was for calcium phosphate. Calcium phosphate, not phosphate, is CaCa3 PO4 2, and we figured out that, whoops, I'll just go ahead and bring that to the next page. So calcium phosphate has a mass of 310.18 grams. That means that 1 mole of this stuff, so 6.02 times 10 to the 23rd units of this stuff, of calcium phosphate, would have a mass of 310.18 grams. And I like to write it like an equality for the simple reason that we can use that equality in calculations. And so just to walk through a sample calculation, and I haven't actually done the math ahead of time, but let's say we had 35 grams of calcium phosphate. And we wanted to know how many moles that was. This is a calculation that you're actually going to need to do on the quiz. And so if we... Actually, I'm going to go ahead and create a little table here. You kind of get a little behind-the-scenes peek at how the sausage is made here. It's all very exciting. And so if we were to set this up like a grid like we've been doing in class, the grid consists of a series of fractions, and the fractions are going to allow us to cancel out this first unit, the one we put in the upper left-hand corner, and get the unit that we want. So if we're asked to figure out how many moles are in 35 grams of calcium phosphate, we would put that mass, 310.18 grams, down on the bottom, because that represents the number of grams in 1 mole. And of course, since the thing that we're asking for is moles, we would go ahead and put 1 mole on the top. That makes sure that we cancel out this, we cancel out these units of grams, and we end up with the unit of moles. And so what we're going to do here is, if you'll excuse my staring at my phone just for a moment, this is going to end up to 3 sig figs, which is probably a good rule of thumb. 0.113 moles of calcium phosphate. So anytime you need to go from grams to moles, the move is to figure out the molar mass and then divide by that molar mass using the fraction 1 mole over the molar mass to figure out your answer. Now let's say we had to go the other way. Let's say I wanted to go 0.473 moles of calcium phosphate. And let's see. I'm afraid this is a bit of a raw video. You got to pay extra for the editor for this thing, so you're just gonna see my whole process here. It's gonna be very exciting. So we're gonna put in another table that's gonna substitute for our grid here, and we'll go ahead and put in our 0.473 moles of calcium phosphate. Maybe stretch that out a little bit. Well, and then we know now that in order to cancel out this first unit, we need to put that same unit on the bottom. And we already know that 1 mole of this substance has a mass of 310.18 grams. So now we cancel out those units, moles here, moles there, and now the move is to multiply 0.473 times 310.18. The rule is you multiply anything on the top, you divide anything that's on the bottom. So 0.473 times 310.18 would give us 147 grams of calcium phosphate. Again, rounded to the nearest, rounded to 3 sig figs. So hopefully that helps kind of walk you through what we mean when we talk about a mole and how we would actually do calculations. So I hope this is helpful, and have a great day.